The core idea behind general relativity is that space-time, the three dimensions of space and one dimension of time, is actually a four-dimensional surface. This surface is flat if there are no sources of mass or energy nearby. So if you've got a flat surface like this in deep space and complete vacuum, objects are just going to travel in straight lines if there's no other force acting upon them. Straight lines are the easiest and shortest paths that objects can take on a flat surface, and that's why objects such as mass-containing particles and light will follow straight lines on a flat surface. But in the presence of a massive planet or a star, that object will not follow a straight line on the space-time surface. That object's going to follow a curved path, like an orbit around that planet, just like how Earth orbits the sun. The reason for this isn't that the sun exerts a force on Earth or vice versa. The reason in general relativity is that the sun warps the space-time surface around it, and by warping that space-time, the space-time surface becomes curved. And when that surface becomes curved, objects within that surface start traveling in curves. And that's because the easiest and shortest paths on a curved surface are curves. So when the Earth travels in a curved orbit around the sun, it happens because Earth is actually taking the shortest path, the shortest curve on the curved space-time surface that develops from the sun's mass and energy. And it's not just the sun. Any object with mass or energy will warp the space-time around it. The relationship between the curvature of the space-time surface and the mass or energy distributed in that surface is given by the Einstein field equations. Your mass and energy are found on the right-hand side, and the nature of your space-time surface is on the left. So if you plug in your mass-energy distribution, you can calculate your space-time geometry, which is given by this g, the metric tensor. The r, by the way, is found from taking the metric tensor and doing a whole bunch of operations on it, like derivatives, etc. It's the Ricci tensor that you can directly calculate from g. And once you find g, you plug it into the geodesic equation. This capital gamma is also calculated from the metric tensor by doing some operations on it. And with your geodesic equation, you can find how particles and light will move on your curved space-time surface. So matter tells space-time how to curve in equation 1, and the curved space-time tells matter how to move in equation 2. That's the essence of general relativity.